Dear students, today we are going to start a new chapter entitled Volumes and Surfaces of Solids of Revolution. So let's start with finding out volumes of a solid of revolution. Suppose we have a curve y is equal to fx and we take the portion lying between x is equal to a, x is equal to b, y is equal to fx and x-axis. And if this portion is rotated about x-axis, then volume generated is given by the formula V is equal to pi times a to b y square dx. In case the curve is x is equal to f of y and the area lying between y is equal to c, y is equal to d, x is equal to fy and y-axis is revolved about y-axis, then the volume generated is given by V is equal to pi times c to d x square dy. Now let's take few examples based on these formulae. First example, find the volume of a sphere of radius a. Now we know that sphere is generated by revolving a circle or semicircle. So suppose the equation of the circle is given by x square plus y square is equal to a square. Now if we take this portion of the circle, now this point is a comma 0, this is minus a comma 0. So this portion is revolved about x-axis. So volume generated is given by minus a to a pi y square dx, which is same as 2 times 0 to a pi y square dx. Now in place of y square we put a square minus x square. So therefore this is 2 pi times integral of a square is a square x, integration of x square is x cube upon 3, limit 0 to a. So which comes out to be 4 upon 3 pi a cube. This is the volume of the sphere of radius a. Similarly, let's find out the volume generated by revolving the ellipse. So find the volume of the solid generated by revolving the ellipse x square upon a square plus y square upon b square is equal to 1 about the x-axis. Now as done in the previous problem, we revolve this portion about x-axis and then we multiply it by 2. So therefore volume is 2 times pi y square dx. Limits for x are from 0 to a. Put the value of y square from this equation, which is b square upon a square into a square minus x square. Again integrated, we get a square x minus x cube upon 3, limits 0 to a. Take 2 pi b square upon a square outside, so we put the limits, we get it as 4 upon 3 pi ab square. Third example, find the volume of the solid generated by the revolution of loop of the curve y square is equal to x square into a minus x about the axis of x. Now because all the powers of y are even, so curve is symmetric about x-axis. If you put y is equal to 0, we get x is equal to 0 and x is equal to a. So we have these 2 points 0 0 and a 0. Curve does not exist when x is greater than a, because in that case a minus x becomes negative and y square becomes negative. So curve does not exist beyond x is equal to a. There is no asymptote because coefficients of x square as well as of y square are constant. So if you trace the curve, shape of the curve is like this. Now this loop is rotated about x-axis. So limits for the loop are for x is equal to 0 to x is equal to a. So therefore volume is given by pi times 0 to a y square dx. Substitute y square is equal to x square into a minus x. So this is pi times 0 to a ax square minus x cube dx. Integration of x square is x cube upon 3. Integration of x cube is x to the power 4 upon 4. Limits from 0 to a, put the limits, we get it as pi a to the power 4 upon 12. So this is the volume generated by revolving the loop of the curve y square is equal to x square into a minus x about the axis of x. Let's take fourth example. Find the volume of the solid generated by the revolution of the cissoid. X is equal to 2a sine square t, y is equal to 2a sine cube t upon cos t about its asymptote. Now this is given in parametric form. We shall solve the same problem in the next lecture when we discuss parametric form. So if you convert it into Cartesian form, then the problem reduces to this form. Find the volume of the solid generated by revolution of the cissoid. Y square into 2a minus x is equal to x cube about its asymptote. Now if you trace this curve, curve is symmetric about x-axis because all the powers of y are even. Asymptote parallel to y-axis, coefficient of y square is 2a minus x, so 2a minus x is equal to 0. That means x is equal to 2a is the asymptote. Y square is x cube upon 2a minus x, so if x is negative, y square becomes negative, and if x is greater than 2a, then also y square becomes negative. So therefore curve does not exist when x is less than 0 or x is greater than 2a. If we could look at lowest degree term equal to 0, we get y square is equal to 0. That means y is equal to 0 comma 0. That means origin is a cusp because tangents are identical. So if you draw this curve, shape of the curve is like this. Now we have to find out the volume when this portion is revolved about this asymptote. So far we were discussing the problems where the curve is revolved either about x-axis or y-axis, but in this case the curve is being revolved about a line which is parallel to y-axis. So in this case there is slight change in the formula. If axis of rotation is y-axis, then we know the formula is pi times x squared dy, limits for y. But if it is rotated about x is equal to 2a, then the formula is pi times x minus 2a whole square dy, and limits for y are from 0 to infinity, and because this curve is symmetric about x-axis, so we multiply it by 2. So therefore volume is 2 times y is equal to 0 to infinity pi times x minus 2a whole square dy, which can be written as 2 pi times 0 to infinity x minus 2a whole square dy upon dx into dx. And now we shall find out dy upon dx. Since y square into 2a minus x is x cube, so therefore y square is x cube upon 2a minus x. Now differentiating it, we have 2y dy upon dx is equal to 2a minus x into differential of x cube, which is 3x square, minus x cube into differential of 2a minus x, which is minus 1, upon 2a minus x whole square, which comes out to be 2 times 3a minus x into x square upon 2a minus x whole square. 2 gets cancelled, so therefore dy upon dx is 3a minus x into x square upon 2a minus x whole square into 1 upon y. Put the value of y from here, so we get this expression. So therefore volume is equal to 2 pi times 0 to 2a x minus 2a whole square into dy upon dx is this one, 3a minus x into x to the power half upon 2a minus x whole raised to the power 3 by 2 dx. Now here we got the limits for x. Because y square is x cube upon 2a minus x, so if y is equal to 0, then we get x is equal to 0. So lower limit for x is 0, and when y is infinite, then denominator should be 0. That means x should tend to 2a. So therefore upper limit for x is 2a. So this comes out to be 2 pi 0 to 2a 3a minus x into root of 2a minus x dx. Now because we have got under root of 2a minus x, so we put x is equal to 2a sine square theta. So dx is equal to 4a sine theta cos theta d theta. So put the substitutions. So therefore v is equal to 16 pi a cube 0 to pi by 2 3 sine square theta cos square theta minus 2 sine theta to the power 4 cos square theta d theta. And now make use of gamma function. So this integral is gamma 3 by 2 into gamma 3 by 2 upon 2 gamma 3 minus 2 times gamma 5 by 2 gamma 3 by 2 upon 2 gamma 4. So if you simplify it, we get the answer as V is equal to 2 pi square A cube. Let's take fifth example. Find the volume of the solid generated by the revolution of the curve y is equal to a cube upon a square plus x square about its asymptote. Now y is equal to a cube upon a square plus x square. So if you cross multiply and simplify it, we get the equation of the curve as x square y is equal to a square into a minus y. Now because all the powers of x are even, so therefore curve is symmetric about y-axis. If you put x is equal to 0, we get y is equal to a, so curve passes through 0, a. Now asymptote parallel to x-axis, coefficient of x square is y, so therefore asymptote parallel to x-axis y is equal to 0, y is equal to 0 means x-axis itself is the asymptote. So if you draw the curve, shape of the curve is like this. Now this curve is rotated about the asymptote, means it is being rotated about x-axis. So therefore we find out volume generated by this portion and then multiply it by 2. So therefore volume is given by 2 times x is equal to 0 to infinity pi y square dx, which is 2 pi 0 to infinity y square dx. Put the value of y square from here, we have 2 pi 0 to infinity a to the power 6 upon a square plus x square whole square dx. Now because we are having a square plus x square, so put x is equal to a tan theta, so dx is a sec square theta d theta. So therefore volume is 2 pi a to the power 6, limits for theta will be 0 to pi by 2, dx is a sec square theta d theta, and then in the denominator we have a square plus a square tan square theta whole square. Simplifying we get 2 pi a cube 0 to pi by 2 cos square theta d theta. So on integrating we get it as pi square a cube upon 2. Now in the last example, the curve y square into a plus x is equal to x square into 3a minus x revolves about the axis of x. Find the volume generated by the loop. Now this curve is symmetric about x-axis because powers of y are even. Now x greater than 3a will give values of y square negative, that means y is imaginary. So curve will not exist beyond x is equal to 3a. For finding out asymptote, highest power of y is y square and its coefficient a plus x. So a plus x is equal to 0 means x is equal to minus a is the asymptote. So if you draw the curve, shape of the curve is like this. Now this loop is being rotated about x-axis. So therefore formula is pi y square dx and limits for x are from 0 to 3a, which is equal to pi times 0 to 3a. Put the value of y square from here, x square into 3a minus x upon a plus x. Now because degree of numerator is 3 and degree of denominator is 1, so therefore to integrate it we divide numerator by denominator. So we get pi times 0 to 3a minus x square plus 4ax minus 4a square plus 4a cube upon x plus a dx. So if integrated we get minus x cube upon 3 plus 4a into x square upon 2 minus 4a square into x plus 4a cube into log of x plus a. Limits are from 0 to 3a. So put the limits, so we get the answer as volume as pi a cube into 8 log 2 minus 3. Thank you so much.